Welcome everyone. I'm very happy to be presenting here today at the Black Hat conference. My name is Ju. This is Moony. And we will be presenting today on the topic of now iOS has been compromised to suspect ransomware. How we hunt and detect profile ransomware in the wild towards iOS. Who we are. I have 5 years of experience in mobile advanced threat research. Now I focus on research on about zero-day, end-day, and vulnerability. I have been working on using automatic system to hunt advanced threat.
Hello everyone, I am Moony, and I am the same team of with Ju, and mainly focus on OS kernel, including Android OS and iOS and Mac. Thank you very much.
As we all know, ransomware has caused terrible disturbance to Windows PC or in the world using remote zero-day SMB vulnerability. And the Apple platforms, especially the iOS operating system, is imagined to be safe enough to be immune to such kinds of security threat because of its declared system security feature by design and restrict Apple Store security policy. However, maybe the first time we have found a suspected ransomware remote attack toward the iOS platform distributed in the wild. In this share, we would like to tell you the whole story, how we hunt for the remote iOS ransomware attack based on profile installation and defect it in cradle. We would analyze how the iOS ransomware hijack your phone screen and even cause system crash or hang using profile installation as we call this profile in technical detail and introduce both static and dynamic solution to detect and remediate such threat. So we would propose one new remote attack interface on our system research. In November 2016, I also profile ransomware version 1 distributed in Twitter, and we named the buggy profile mechanism as this profile. But in fact, this is a fake jailbreak website. They also use this to trick victims into downloading and installing it. The next day, the author just released its source code on GitHub. He also provided a web tool for generating a malicious profile of any number of icons. Any bad guy can build his own malicious attack profile by this tool. In December, iOS profile ransomware version 2 distributed in Twitter. The author has made some improvements. Its purpose is to directly support mobile safety and open multiple installations operation. However, this is only a demo, but it has turned on multiple installations. Later, he was arrested, and he is just a boy. We found that after multiple installation, a weird icon appears. Springboard's icon has overflowed. When we click on it, Springboard will crash because of Watchdog timeout monitoring. Generally speaking, we can uninstall a malicious profile through settings general or Apple configurator to remove profiles. But after the crash, these malicious icons will reside in your system forever. That means we cannot use any tool to remove them unless you restore factory settings. In addition, we found that they were using tricks to make users fearful of being unable to delete them. This tool was once sold in online market and it has been successfully traded. In fact, Apple has a migration mechanism for install on no profile. Apple would use highlight not signed to warning user, but a bad guy can still use a single profile to conduct similar attack. What is more interesting, about 1 month later, we have found a real desk profile attack in one third-party Apple store in our threat hunting system based on the desk profile pattern learned from this malware. If user access this site using a device, it will allow user to install a single profile. All the web clip icon are removable and link to popular applications in this store, which are repackaged from official ones. This kind of malicious profile is actually a configuration profile. There is also a profile called a provision profile. We found that iTunes had a risk. It can auto-sync all provision profiles in a fixed directory to a device without checking the owner of this directory. Maybe this will be part of an attack chain. Moreover, we also found that a vulnerability can bypass established trust mitigation mechanism by attacking the installation of the provision profile. What is a profile? As Apple documents say, a configuration profile is an XML file that allows you distribute the configuration information. If you need to configure a large number of devices or to provide lots of custom email setting, network settings, or certificate to a large number of devices, configuration profiles are an easy way to do it. A configuration profile contains a number of settings that you can specify, including restriction on device features, Wi-Fi setting, VPN setting, email server setting, Exchange setting, web clips, and also on. At the top level, profile property list contains the following keys. The web clip payload is designed by specifying com.apple.webclip.managed as the payload type value. This value defines the following keys. Yellow highlight can be abused. There exists multi-removed entry for profile installation. Some system application of Apple would automatically download the removed profile and recognize the profile format and trigger system daemon to handle. For example, any user could simply click the hyperlink or profile in website or click the profile as the email attachment. So how does the author do that? The author will create a template on his server. This template will be set unremovable. When the browser accesses this page, the template will be downloaded first. Then we modify payload identify and generates a new malicious profile for multiple installations. Next, we would analyze the core part of the iOS Ransomware configuration profile installation in detail. We would not only expose the root cause to Ransomware user's screen and system process crash, but also propose a new attack interface for iOS phone attack. The remote entry, for example, safety email process would then trigger provide daemon process for specific installation. When profile installs the downloaded profile, it triggers setting to interact with the user. The provider will create the profile system for the enable profile.stop in its profile install handle. There exists a vulnerability or weakness when provider analyzes the profile. It did not check web clip number limit declared in profile so as permitted the malicious countless profile occupy the whole screen. What is more, we have found some memory corruption in the profile installation part, which strong hint profile would be a buggy module. Actually, the profile saved would be read and analyzed by other demo process with high privilege, for example, LaunchD, or proxy process, for example, misagent to high privilege. For example, misagent would be triggered to enumerate installed profile and which would XPC with lockdown daemon with router privilege. At the real vulnerability, we have found a Springboard process would be heap overflow when read in huge amount of web clip icon to show on iPhone screen. This is the whole attack chain. The provider installation would be a new remote attack interface for iOS device in the future as we expected. One profile install is a natural remote attack interface which bypass the Apple Store security audit and app install check. Many demo processes would read the profile content with which hint that attacker which exploit the the high privilege process related to profile step by construct buggy profile content. For example, safely to provide to misagent to lockdown D. Actually, we have found serious vulnerabilities about profile mechanism based on remote profile install. Provider 1 and other system process heap overflow. The root cause is that profile-related process did not check the limitation of a web clip payload number in one malicious profile. We have found a Springboard process crashed when huge amount of web clip are installed. Springboard manages the home screen and control how apps are displayed and launched. Like Springboard crash because of Watchdog's timeout. To enterprise certificate app trust vulnerability. By finding the profile installer operations, we found a new related vulnerability again and exploited them to bypass enterprise certificate app trust under some conditions. Because Apple has not fixed it, we cannot publish too many details. Very sorry. When Springboard's vulnerability are triggered, we found that its process had a high CPU. Then we analyzed the Springboard dynamic call stack. We found a 9-point reference and a data loop. Back to Springboard code, we found the final issue function by analyzing the function call flow. Anyway, and we found that because V6 is equal to 0, that leads to V18 which is equal to 0. Springboard goes into the data loop.
Okay, so we have this site. We have harnessed the vulnerabilities of profile installation on iOS, and also we have found the new attack interface for iOS platform. So the next step is how do our security vendors such as Trend Micro to detect and defend such kind of attack. And here is our solution. The whole solution is composed of two kinds of parts. The first part is in the real machine endpoint user using the local VPN feature. And the second feature is in the backend system, which is based on FRIDA hooking system. And we will introduce the two kinds of solutions for you in detail. Okay, as the first kind of VPN, local VPN feature to detect such of attack, we can see that iOS has introduced a VPN setting here, and you can turn it up if this app from Apple Store is required you to turn the local VPN feature on. And we can see that this kind of local VPN is lack of web traffic filter in your local endpoint devices, which is introduced since iOS 8 or iOS to iOS 11. So, another kind of solution for detecting kind of attack is using dynamic sandbox. This kind of solution is based on the backend, and which will use jailbreak iOS devices. And we will put some hooking and rule decision system on such kind of system. Okay, about the local VPN solution, you can see the overall architecture of the view. And the left part is of iTMMS endpoint app, which you can download it from Apple Store. And we can see that here is the web traffic processing module, which is based on the feature of network extension. Using this kind of feature, the iOS platform allows the app developer to get the traffic from the user point when the user try to, for example, browsing the email or browsing the website and so forth. And the local VPN will try to extract the traffic in the local user end and try to, for example, try to extract the file and the picture and the mobile config, such as the data profile and the IPA file and so forth. All kinds of file content can be seen using the local VPN feature. And we will use this kind of feature to try to extract the file content when the user trying to browsing the .mobile profile, and we will try to get the content and detect the file content. Okay, so the basic feature, the basic workflow is that we will. This is the basic workflow, and another kind of detection solution is in the backend. This is the whole picture. You can see that this part is based on the jailbreak iOS devices, and the left part is on the iOS devices, and the right part is on the host machine, and they are connected via the USB using the iTunes protocol control protocol. And we will use the FRIDA server, which is open source. He will allow you to hook any system process easily at any API and at any steps of the life cycle of the process. For example, we will set our FRIDA hook to, for example, the Safari or the also email process and the profile D and the misagent process. And all these kind of behaviors, trace logs of the from the FRIDA server is collected via the USB or Wi-Fi to the host server. The host server will use the, for example, our decision engine, which is based on the Ju rules. Ju rules is kind of a security-based reasoning system, which is also opened. And we will add some data profile JavaScript as the rule. Okay, this is log server, and this part is the rule decision. And we will give you the picture of the trace log in detail. You can see that all this kind of trace log is collected from the FRIDA server using our hooking system. You can see that we will hook, for example, file system read or write API, and this is the whole code stack with the parameter, which will involving different kind of frameworks and modules. And in the down bottom, we can see that the file system read or write is towards the private configuration profile, which is the data profile. We can also see the data profile file name in the file system, and we also get the file content of the data profile. And this is our decision rule. This decision rule is also security-based in JavaScript. Its semantic is also clear. You can see that we will try when we get the trace log at the file system read or write towards the data profile, and our decision engine will try to extract the file content and analysis its content by pattern. For example, if the data profile configuration contains the payload such as com.apple.webclip.managed, and also it has the property of is unremovable with false, then we will decide this kind of web clip is portable malicious. And the rules can be correlated with different rules together, which will make you get the better decision. Okay, in the last part, we will introduce two kinds of demos. One demo is the real data profile, which will which will crash your iOS system. And another demo is about the dynamic sandbox solution at the endpoint to detect such kind of attack. Okay, we will see the first demo.
In any iOS user, click the malicious web server and load to install a malicious profile. The user screen would be provided by large corners. The icons actually web clip. The web clip icon personal header with name YJSMPI could be not removed manually, so as frighten the RS user and also cause system process harm or even machine reboot. But after the crash, this malicious icon will reside in your system forever. We cannot use any tool to remove them, including Apple Configurator 2. Non-profile。OK， 继续。第二个那个位置打开。好，第二个。哎，你这个回来。不对，先把这个。上拖一下，拖一下。这个切换是比较麻烦。哎，不对，应该是先直接打开。哎，哎，哦，这个拖到这个。这样。OK， 我来帮你吧。行，我来帮你。你来控制。
And this demo is about the detection solution of that profile. And we can see that the left iPad is a real machine which is jailbroken. And also we have deployed the FRIDA tracing system and in the iPad. And the right host is the controller on Mac. And we will the controller is also on this side. We can see that this is the real-time tracing log when we try to installing the profile using the email as the attachment. Okay, we can see the call stack and the file content of that profile. And the using the FRIDA trace, we can see that the iOS profile installation will involve different kind of processes, such as Safari, email, and the profile D, which is the daemon process of iOS service, and also the miss agent and launch D process. This is the file content and the with the timestamp. Okay, and this is the rule decision part. After the tracing phase is finished, we will use the G-rules decision system with the data profile rule. So we can see that after the decision system, the final result is colored in red. Here. This is the malware name and the reason to get this kind of result, because it contains several 4 kind of web clip and all with the feature of is removed with false, and each rule is scored with specific score. Okay, this is our. This is a folder, and the rules source file. Okay, thank you. This is our final demo. Okay, thank you very much. Anyone have a question? Or we will talk after the conference.